Hey everyone, welcome back to Python Code Nemesis. In today's video, we'll be understanding deadlock situations in databases with Python. Deadlock is a critical concept in database management systems that can lead to system halts and performance degradation. In this article, we will explore deadlock situations and how they can occur and demonstrate in a simple Python example to simulate a deadlock situation using a SQLite database. What is a deadlock? A deadlock occurs in a database system when two or more transactions cannot proceed because each is waiting for a resource held by the other. This creates a circular chain of dependencies, preventing any transactions from progressing, effectively causing a standstill in the system. Common causes of deadlocks. Deadlocks typically arise due to four conditions, known as deadlock detection conditions: mutual exclusion, resources cannot be simultaneously shared, hold and wait, transactions hold resources while waiting for others, no preemption, resources cannot be forcefully taken from transactions, circular wait, transactions are waiting for each other in a circular chain. Let's simulate a deadlock situation using Python and a SQLite database. We'll create a simple scenario of fund transfers between two accounts using threads, introducing a delay to induce a deadlock. So how this code works is that we establish a SQLite in-memory database and create a simple profiles table here. Next, we define the update profile function to simulate profile updates. The function begins by connecting to the in-memory database and defining the profiles table. So this is the function. Simulating profile updates through threads. Two threads, thread 1 and thread 2, are created to execute the update profile function concurrently. Each thread attempts to update a different user's profile by combining their names. Right. Introduction of a delay to induce deadlock. To increase the likelihood of a deadlock, we insert a delay of 1 second using time.sleep within one of the threads. This delay creates a situation where both threads wait for each other. Let's say there's threading, thread 1 with the target is update profile with these arguments, user 1 and user 2, and this one just takes user 2 and user 1. And we have a time.sleep. The two threads start simultaneously after running the code and initiate profile updates. However, due to the introduced delay, one thread enters a waiting state, expecting the other to release a resource. The second thread encounters the same situation and also enters a waiting state. As a result, both threads remain in a state of waiting, leading to a deadlock scenario. Deadlock situations are critical issues that can affect the performance and responsiveness of database systems. Understanding the conditions that lead to deadlocks and exploring examples like the one we just looked at will help developers better grasp the importance of implementing strategies to prevent and handle deadlocks. While the model presented here is a simplified scenario, real-world databases employ advanced techniques to detect and resolve deadlocks, ensuring the smooth operation of critical systems. That's it for this video. Thanks for watching. If you like this video, please like and subscribe. Happy coding!